Hello everyone. Today I want to show you how we can find the solution to this integration from 0 to pi over 2 cos x dx using numerical integration such as composite, midpoint, composite, trapezoidal, and composite Simpson rule. So we know the exact solution to this. When you integrate this, it will give you sine x, sine pi over 2 minus sine 0, so sine pi over 2 is 1. So this is my exact solution. Okay, so now let's see how close your approximation will be by using composite, trapezoidal, composite midpoint, and Simpson rule. Compare with the exact solution. The first method that I'm going to use is composite trapezoidal. Okay, so let's say I want to divide the interval to 6. So we want to use n equals to 6. Okay, the composite trapezoidal rule is given as Tn equals to b minus a over 2n f of a plus f of b plus 2 summation from I equals to 1 to n minus 1 f of a plus ih. Okay, so this is a formula. Now you have to Google it to see how you can derive this formula. So I'm not going to show in this video. Okay, so what I want to do is I want to divide this interval first. So you have 0 and you have pi over 2. So these are the given AB. This is my A, this is my B. Now divide this into 6. So we have 1, 2, 3, 4, 5, 6. So we have x0, x1, x2, x3, x4, x5, and x6. Okay, with this information we have, we can find h. So h is b minus a over n. Okay, my b is pi over 2, a is 0, my n is 6. So we have pi over 12. Okay, so you have to, so my interval here at pi over 12 up to you obtain pi over 2. Okay, since we have all this information, let's use T6. We have, this is b over a minus over 2. And so we have pi over 2 minus 0 over 2 times 6. Okay, 12 times 2, 24. So pi over 24. Now I have f of 0, a 0, plus f of b, b is pi over 2, plus 2 times, now I start from 1 to n minus 1, which is 5. Okay, so we have f of a, which is 0, 0, so 0 plus ih. Okay, so let's simplify this. We have pi over 24 f0 plus f pi over 2 plus 2 times f, and I is 1, 2 times f, my h is pi over 12 plus 2 times f. When I is 2, we have 2 times pi over 12 plus 2 times f, 3 times pi over 12 plus 2 times f, 4 times pi over 12. I think you get the idea, up to 5. Okay, up to 5 here. Plus 2 times f, 5 times pi over 12. Okay, don't forget all this. It's a big summation here. So we know fx is cos x. So we have pi over 24. I have cos 0 plus cos pi over 2 plus, okay, so first we have cos. So let's do 2 here, 2 here, 2 cos pi over 12 plus 2 times cos pi over 6, okay, and then pi over 4 plus 2 times cos pi over 4 plus 2 times cos pi over 3 plus 2 times cos pi over 6, 5 pi over 12. So we have 5 pi over 12. Okay, so now you need to find all this value with your calculator and key in for the solution. So we have cos 0 is 1, cos pi over 2 is 0, so don't bother about this one. Cos pi over 12, pi over 6, pi over 4, pi over 3, and 5 pi over 12. I can use my, I have my MATLAB ready to calculate this value. So first is cos pi over 4, and you want to find cos pi over 3, and you want to find what else? Cos pi over 12, pi over 6, cos pi over 12, and cos pi over 6, and cos 5 times pi over 12. Okay, so we need all these values here, so to key in and find the answer. So let's do that. So we have pi over 24, cos 0 is 1. I'm ignoring the decimal point at this stage, but in the end, please don't forget your decimal places. Okay, cos pi over 12, we have 0.9659 plus 2 times cos pi over 6, 0.8660, and then we have 2 times cos pi over 4, pi over 4 we already calculated. 2 times cos pi over 4, we have 0.7071 plus 2 times cos pi over 3, 0.5, and 2 times 5 pi over 12, 5 pi over 12, 0.2588. Okay, there's a big summation here. So you gotta use your calculator or use MATLAB like what I did just now to find this solution. Okay, so using this, we have, solving for this, we have 0.9943. Okay, so this is by composite trapezoidal rule. I have less than 4 minutes. Maybe I can show quickly how we can get what's the solution for composite midpoint rule. Okay, composite midpoint is given as mn equals to b minus a over n summation I equals to 1 to n f of a plus 2i minus 1 h over 2. Okay, now having this, so what we can do here, we know that we wanna find n equals to 6. So m6 will be b is pi over 2 minus 0 over 6. Now summation here, let's find the summation. So when n from 1 to 5, so when I is 1, we have f of a is 0. When I is 1, 2 minus 1 is 1, so we have h over 2. H is pi over 2. Pi over, what is h? I forgot. What is h? So h is pi over 12. Okay, this is h. Pi over 12. So pi over 12 divided by pi over 12 divided by 2 again. So we have pi over 24. And then plus f of 0 plus, okay, forget about this one, this is 0 because a is 0. So we have when I is 2 times 2, 4 minus 1, 3 h over 2. So 3 pi over 12 times 2, 24. Okay, and then plus f when I is 3 times 2, 6 minus 1, 5. 5 pi over 24 when I is 4 times 2, 8 minus 1, 7. 7 pi over 24. Lastly, I 5 times 2, 10, 9. 9 pi over 24. Okay, so these are, you need to get all these values here. So I have pi over 12 cos pi over 24 plus cos 8 pi over 8 plus cos 5 pi over 24 plus cos 7 pi over 24, and lastly plus 9 divided by 3, 24 divided by 3, 8. So we have cos 3 pi over 8. Okay, so this is a matter of pressing your calculator. 0.9687. So this is by composite midpoint rule. Now lastly, I want to show you if you, what you get if you use composite Simpson rule. Okay, so Simpson rule is given at S6, when n equals to 6, h over 3 we have f of x naught plus f of x6, which is my xn, plus 4 times, now the odd intervals are x1 plus f of x3 plus f of x5, okay, and then plus with 2 times the even interval f of x2 plus f of x4. Okay, so these are the Simpson rule. Now if you're not sure what are the x1, x2, so just look at your interval again. You have from x0 to x6, which is my xn. Now I have x1, x2, x3, x4, and x5 here. Now the limit is given from 0 to pi over 2. I already said that h is b minus a over n. So b is pi over 2. So we have pi over 2 minus 0 divided by n is 6. So h, which is step length, is pi over 12. So each this add by pi over 12. So my x1 is pi over 12, my x2 is pi over 12 plus pi over 12, 2 pi over 12, so which is pi over 6. Now plus pi over 12 here gives you pi over 4. Now plus pi over 4 here will give you pi over 3, add another pi over 4 here, give you 5 pi over 12, and check. If you add another pi over 12 here, 6 pi over 12, which is pi over 2. So your interval you have divided equally. So these are my x1, x2, x3, x4, x5. Okay, now the method is putting into here and calculate for x6. So we have pi over 12 divided by 3. So we have pi over 36. F of 0, x0 is 0, and xn is pi over 2 plus 4 times f of x1, pi over 12, plus 4 times f of x3, this one. So like I say, all the odd interval times with 4. x3 is pi over 4 plus 4 times f of 5 pi over 12. Okay, now plus 2 times, now the even interval, pi over 6 and pi over 3. So we have 2 times f of pi over 6 plus 2 times f of last one, pi over 3. Okay, so once you have written this, it's easier for you to put it into your function, because we know that we want to solve fx integration of cos x. So my function is cos x. So we have pi over 36. You have cos 0 plus cos pi over 2 plus 4 times cos pi over 12 plus cos pi over 4 times cos pi over 4 plus 4 times cos 5 pi over 12 plus 2 times cos pi over 6, and lastly plus 2 times cos pi over 3. Okay, so make sure when you are using your calculator or any calculation tool, this is in radian. okay, unless you want to change it to degree, but this should be in radian. So surprisingly, when I hit the calculator and multiply with pi over 36, I will get the solution exactly like the exact. That's how accurate my order for Simpson rule. Okay, so you can check the error by subtracting exact approximation minus exact, but I'm not going to do that. Okay, so you know that Simpson rule, which is order 4, can give you very accurate result. Okay, now different values will obtain if you divide different n intervals. Okay, but this n equals to 6 is good. Okay, that's all for today.